Day 3. Let's go. Do this one today. Alright. Oh, I should set this up. I'm gonna start using this for now. And quickly sign into my account. Man. Okay. And we are back. You should be able to see this, right? Okay. I should. New section. This new section should call Leetcoding. Okay. Let's call this page day 3. Valid Anagram. Cool, man. All right. I need that. Oh yeah, that's much better. Okay, cool. Given two strings s and t, return true if t is an anagram of s and false otherwise. Given two strings s and t, return true. An anagram is a word or phrase formed by rearranging the letters in a different word or phrase using all of the original letters exactly once. So basically, I just take all of the letters and then see if they are see, because like, my first thought right away is just do it like how I did the last two questions, where I use a hash set. But isn't it like in a hash set, you can only have one number or one character once? So then how are you going to account for multiple, like What if one word has 3 A's and the second word has 4 A's? What if what if I use a hash table and then there's a hash table and then make the index, no, not the index, the key into a letter, from the let's try like this. How do I like? Oh, I can't type. Oh, I can. So let's say S equals anagram and T equals, yeah, okay. Let's say this for now. If I make a hash table, is the key and the value. It's terrible. And I set like 3 A 1 N 1 G 1 R 1 M. Okay, anagram. Okay, that makes sense. So now I have a count of each. Now I just have to compare it with T. What do I compare? Do I have to create another hash table for that one too? It seems inefficient. So once I create it, so let's say I create it with like S. Now I have to compare it with T. For T, do I want to make another hash table or do I just want to be able to compare it directly? I should be able to compare it directly, because if at any point it deviates or like they don't match up, I just return false and say like, hey, this is not a valid anagram. That makes sense. That makes sense. Okay, let's try that. Let me see if I can remember. It was like unordered set Okay, so now I need to actually pass each, I need to basically parse through S, break it down, and then send it to my set. Is that the same? I don't know if that's the same actually. Unordered map. That's what I need to do. I want to see something. So I was thinking about it wrong. So I should actually be. Oh, keys must be unique. That's pretty huge. Keys are the identifier. So it will be like, oh, I messed that up. It'll be like, it'll be like that because the keys have to be unique and these can repeat, right? Multiple keys can map to the same value. Okay, cool. So this will be unordered map. That will be the other way, char int. Right? Yeah. Don't need that. Char int anagram checker. Now I need to parse through each. So let's go like 4. Can I do it like how I did yesterday? 4 char letter and S. For char letter and S. Wait, can I just do that? Because string is technically an array. Oh my god, wait a second. Oh. Doesn't really matter. Oh my god, that's huge. Oh my god, that saves some time. Okay, so now I can just put it just straight in, right? Anagram checker. Oh, I can't. So first, here's what I have to do. First, I have to actually check if it already exists. Maybe I should. Letter count. So I just want to make sure that I'll count if it's already in there. I just want to change the value. I only want to change the value, not the key. Yes, I just want to add one to it basically. Okay. If anagram checker dot count will this work? Letter. Then, so if it's already in there, all I want to do is do anagram checker letter equals letter count. So if it's already in there, first I want to increase the letter count, and then I want to assign it. Else, if it's not in there, then I just want to add it. Anagram checker. How do I add something? What does that mean? No, I want this to be 1. Yeah, not 0, because if it's already in there, if it's already in there, yeah, if it's already in there, then I want to actually reset it back to, if it's already in there, I want to add 1 to it, so it should be 2 because it's already in there. If it's not in there, then I want to make sure it's 1 again, and then anagram checker letter count. I could take this out and put it right here. Right? Oh, the snippet iterates all over all key value pairs. So this is how if I want to see it. Okay, that's actually pretty useful. Range-based loop. Range-based. What does constant auto do? Declares a constant reference to each pair. That makes sense. You're referring to the memory address. Oh, it makes it constant so it can't be changed. I see. Should I do that? No, because I do want to change them. Yes, because I do want to change them, so I should not do that. What does auto do? Access the key of the current key value pair. Pair dot first value. That makes sense. Because it's called pair. Okay, okay. Oh, dude, that's sick. So I can just say auto, and then it will automatically figure out. It'll just automatically figure out what type it is. Oh. Dude, I didn't even know C++ had that. Oh, that's something else. This is cool, yo. That just makes it so you can't change it anymore. Okay. Oh my, that's huge. Is it? That seems pretty cool to me. Sick. Okay. Actually, let me do that. That's a good point. I should just see what it looks like before I move on to the next part. Just to make sure, like. Okay. Just want to be able to write it out myself. Const auto. Oh, that's not good. That's not good. Oh no, it is good. It's fine. So M1. Why is it starting at M? It should start at A, no? Oh, it's just. Oh, okay. Never mind. I'm being dumb. Does an anagram have 3 A's? Yeah. Should be 3. Okay. Let's think about it like this, okay? On the first check, it picks A and it checks, is it already in there? Okay, it's not in there. Then it makes letter count equals to 1, and then it adds it to the hash map. Then, second round, it goes to n, and is not in there, sets letter count to 1. Okay, do I need that? I don't think I need this. I think I need to do it after this, no? Letter count was 1. No, I don't want to do that. That's not good. Oh, that's the issue. Okay, the issue is, so it will go, oh my god, can I just go like, so the issue is, it will go the first time, then it'll do A, and then it will go to N. It will go to N, and then it will go back to A. It will make letter count 2. Then it will set letter count back to 1. So when it finds a third one, it's still just overwriting. It's writing 2 as 2. It's not doing 2 plus 1. It's doing 1 plus 1 again. Okay, that's not what we want. We want it to actually reset. Should be like pair.second. Can I do this? I don't think I can do that. What does that mean? Oh no, it shouldn't be called pair. It should be called letter. Should it? Member reference base type char is not a structure or a union. Oh. Because we're just accessing only the letter in the string. We actually want to let's go Anagram checker letter. There's no way, right? Just remove this line. I don't think this is gonna work. Oh! Oh my god, it worked! Oh my god, that's huge. That means I don't need this anymore. So A is 3 times, N is 1 time. Okay, we do not need this. It's fine. M is 1 time, yes. R is 1 time, yes. G is 1 time, yes. N is 1 time. T is 1 time. Oh my god, huge. Okay. Okay. We're making progress. We are making progress. Now, so we have, okay, cool. So now we just got to this part. Now we've made the hash table. Now we need to figure out how are we gonna check that against, how are we gonna check that against string T? Should I just do the same thing? I just go like, oh, I just didn't mean to close that. Okay. Yeah. Okay, so we have this thing. Now we need to compare it to the second one. The way I'm thinking of comparing it is if I just like off the top of my head, the easiest way I can think of is I just do the same loop. I just do the same thing. I parse t. I parse t. Wait a second. Can I parse both of them at the same time? Because they're always going to have the same amount of letters. Oh my god, yes. They're always going to have the same amount of letters. If they don't have the same amount of letters, then it's automatically false. Right? Should I add that? Is that like good coding practice? Let me just add it, whatever. If s dot size does not equal to t dot size, return false. Right. That makes sense. Let's try this. Should work. Hey, that's good. Okay, I don't know if that actually helps, but that should, like, it should be a clear, like, right away this is 0. And that should, hey, whatever. It doesn't matter. Small thing. What we want to do is I want to see if it's actually possible. First of all, let's get our first thing out, okay? Let's just figure out the most simple way of doing it. Just do it like this. Char letter T if anagram checker count letter wait, I want it to be if it's not, because I want to see, I want to compare both. I don't want to just compare one, right? Anagram checker dot count letter. So is the letter in it? Is there a way to check? How do I check for entries? Key pairs. Oh, that's sick. The CPP, the count function returns the number of elements with the given key. Oh, that's huge. Wait, is it? So basically it just returns, oh, okay, that's something actually pretty important. Use find to see if the key exists. Compare guess. Dude, this is so sick. You can simplify iteration with structured bindings. This is cool. So basically, I want to see. Syntax super is almost in the correct way to use it. So what's wrong with my? Wait, so what's not correct about it? Oh, okay. So you just always use auto. Okay, I just want to double check. Like, I just want to know if it's possible. Can I? Okay. So constant. Okay. Something cool, I guess, that we learned. Okay, what was I doing now? Right. So now we want to do it like this: const auto, and then we're gonna reference the key and value pair. No, this should be in here. Value while we're iterating through anagram checker. Anagram checker. Now we're working through the anagram checker. Okay, so it should give us two values. Now we just check is key No, but we also want to iterate through. I feel like I'm getting on the wrong track. Okay, let's think about this. We have the hash table, hash map. Now we are checking against. Now we're checking against the other one. Might be better. Man, I don't want to make two hash maps. That's the thing. I feel like that's not good. You know? I feel like. Is that what I have to do? Actually confused, man. I actually don't know where to go. Or like, even like, I know what I want to do. I want to see if the string t is equal to this hash map. But how do I do that? Do I iterate through every okay? Do I iterate through every letter in t? And then if I do that, wait a second. Yeah, let's try that. Let's try letter as t if anagram checker dot so anagram checker dot count letter will let us know is if that letter actually exists. If it exists, now I want to check what its value is. But for that, I need to also know how many times it exists in t. Okay, we checked if it exists at least once. Right? If anagram checker dot count letter, it exists at least once. Okay. Wait, let me see if I'm doing anything here. If it doesn't, return false. Okay. Okay. Now we have made it so that it will go through the array. If it doesn't, if it doesn't exist at all for any of the letters, it just returns false, says it's not true. That makes sense. The only part I'm missing now is how do I know if, or like how do I know how many times a letter is repeated? Because a letter could be repeated 2 times, 3 times, blah blah blah. I have everything else. Okay, let's think. I need to reference and figure out how I can get that back. missing a bracket? This should never come here, right? I know this is not right, because as soon as I make it like let's try this. Right. It should not work anymore. It should return false. Oh no, it returns true because yeah, it returns true because it's returns true because it's just checking. It's not checking like how many times. Okay. You know what? Let me ask ChatGPT. I'm doing valid anagram. Leetcode. Give me a solution. But help me. Wait a second, what is it saying? You're returning true or false immediately after checking the letter exists in S. This will not work. Okay, we know that. I need to decrement the count for each character in T that exists in S. If a character's count becomes 0, it means you have matched all occurrences of the character. For each character, check if it exists in Anagram checker, okay? If it doesn't, return false. If it does, decrement the count. What, man? I think there's some thing in my code that I haven't removed. Oh yeah, this. I don't actually need this. Okay. Let's try this again without the count. Because I'm just thinking, like, is there an approach that doesn't require count? Properly decrement the count or handle cases where the counts are not matched. This can lead to incorrect results. Okay. Yes. Okay. So see, we're on the right track. I know where the problem is. Yes. If it exists and the count is greater than 0. Damn, it's just giving me an answer now. Okay, that's what we have. If anagram checker dot count and anagram checker. Oh that's sick. Okay. So I can just decrease the value. Whoa, I want to. Anagram checker is greater than 0. Okay, this is kind of cool. This is kind of what we needed. But then why isn't there an else if to see if count is 0? Oh, because if it's because it's like this. It has to be greater than. That makes sense. Because if either one of these are incorrect, then it's false. Makes sense. Okay. So, okay, this is how it's telling me to count. So I go anagram checker dot letter 0. Oh yeah, because that's what I did. That's what I did here. I'm assigning a value pair to it. So now I can just go anagram letter, and then I can check. Oh, okay. And then just how I did plus, I remove now. Oh, it's my alarm. Anagram checker minus. Okay, so we don't have a return true condition here. Now the only thing that it said that we need to check is if we need to check if all of the counts are 0. Right? For processing both strings, all counts in the unordered map should be 0. Yeah, because what if there's something in the S string that isn't in the... Dude, I feel like... Wouldn't this just work? Because look, they're both the same size. Both strings have to be the same size. What's the case where it wouldn't be 0? Do we really need that check at the end? Am I tripping? Oh. Yeah, why do we need that last check? Why can't I just do it like this? Why do I need this? This code not removed. But okay. Yeah, like we shouldn't have any leftover characters because we're checking the same size. Yeah, exactly. Okay, sick. Okay, okay, let's go. Let's go. We beat ChatGPT. Alright, let's try it. Let's go. Got him. Okay, sick. Um, I want to see if there's a. Let me open it. Can I open a new tab? Whatever. Easy solution in C++. No, I want to make it most votes. There we go. Oh. Oh, that's smart. Yeah, you can just sort it. I didn't think about that. Sort s dot begin and s dot end. So, okay. That's kind of cool. Hash table. This is what we did. Create an unordered map to count, store the character frequencies. The keys represent a character value. Okay, that's what we did. Iterate over each character x in string for increment its frequency by using the count. Oh, count x plus plus. Oh. Okay. Wow, dude, this code is so like small. Yeah, like it doesn't have like any if or wow. It just has 3 loops. I guess we have 2 loops. Count the frequencies of characters in string S. Decrement the frequency of characters in string T. Check if any characters has a non-zero frequency. This is cool, bro. This function, this code seems so like small and clean. clean. No, I'm just thinking like, how would, can I just go count x plus plus? Dude, yeah, I can. Okay. Um. This is a dumb question. Okay. Okay. Um. Yeah. Okay. It should just be O of 1 still. Sure. I mean O of n complexity. Same with space. It's O of n complexity. Just double checking. O of n. Also O of n, right? Second loop. Okay. Oh wow. Wait, I need to see. Wait, that's kind of cool. Stores a count for each unique character in the string S. In the worst case, if all characters in S are unique, the strings are all lowercase letters. The unword map will contain O of 26 entries for the English alphabets. For other characters, oh, that's pretty sick. Wait, so why isn't this guy saying O of Q? Well, I guess he didn't even say. He doesn't say spice complexity. cool, man. Sick. It's pretty cool. Okay. If compare length of both strings. Initialize a hash table or hash map. Iterate through every character in string S. Check if the value for a letter in the hash map is greater than 1, which is just like the same. Okay, if a letter exists in the hash, and yes, hash map. If it exists, increment else doesn't exist. Exist? That's not it. I'm just thinking, like, if it doesn't exist, I should still like I see what the other guy was doing now. What he was doing is that he doesn't need to check if it's one. It doesn't need to check if it exists or not. Because if it doesn't exist, you increment it by 1. It's just going from 0 to 1. If it does exist and you increment it, it's going from 1 to 2. Right? So it would be better, like how that guy did it, if we just made it anagram checker letter plus plus. This is just increment value Yeah. Iterate through every character in string T. Check if the letter exists. And at the count. Wait a second. If the letter exists, can a hash map value be 0? Oh, okay. Okay, so it can be 0. We don't want it. So we do want to check if the count is 0. I was thinking if it just exists, I can always just decrement the letter. Can it be negative? Oh, it can be negative, right? Okay. The letter exists and the count is at least 0. No, it's at least 1. Yes, because if it's 0, it doesn't exist. And then it should return false. Okay. If it exists, decrement count by 1. If the letter does not exist, or the count is 0, which means the same thing. Wait a second. If it means the same thing, can I just do if anagram checker letter is greater than 0? Like why do I need to make sure it exists? Right? Because if it exists, like it doesn't matter if it if it exists, no, that's not what I'm saying. There is a possibility that it exists and the letter is 0, but the possibility, it can't have a number that's larger than 0 and for the count and for it to not exist. That makes no sense. Right? So I should be able to just remove this. Value for current letter is at least is not equal to or less than. No. Current letter is greater than 0. Zero. It shouldn't be less than 0 ever, but if it's 0 or less. If the letter count is 0 or less, this means that does not exist. The letter does not exist, and it is not equal to the original, to this. The strings cannot be equal. Cannot seem letters and frequencies. If all anagram I just want to check if this actually works. Okay. Oh wow. Did it get better? Let me ask ChatGPT what changed. Is this code better? Instead of using count to check if a letter exists in the map, you're directly accessing the map using anagram checker letter and checking if the value is greater than 0. Yeah. I wonder if adding that is good. Because if okay, I get why it's doing that. Okay, I think this code is now good. So let's do the solution now. Day 3. I don't know what I wrote yesterday. Leetcoding every day. Comments on every line. Sure, let's just write comments on every line. We know time complexities O of n because as the inputs increase, I'm using a for loop, so it takes longer time. Space complexity, which I learned today, is 1 because well, the hash map can only have a finite number of entries. It cannot have like n entries. If every entry is, because there's only 26 letters in the alphabet, so it can only have 26 entries. Even if I was to include like numbers, even if I included emojis, there's still like a finite number. It's not really n. Yeah, exactly. It's not like put a number in where it can be like you can put any number. There's still a constant amount of characters. Yeah, constant amount of characters, so that's why. That makes sense. Approach. Check if both strings are equal size. If not, do not be anagrams and return false. Okay. Initialize hash map. Yeah, I'm not sure if that's how you spell it, but it's fine. Just together. Hash map. Through each letter in string S, add it, hash map and increment its frequency every count every time it occurs once. That makes sense. I'm not incrementing for every time it occurs more than once. I'm incrementing it every time it occurs, not just more than once. Okay. Now that I've put everything in, now go through each letter in string T. Remove, or no, decrement the value in hash map for that character every time it occurs. Value, okay. You know, I I think I should whenever it occurs, decrement its value in hash map. Yeah. If it occurs in string t, but the is that how I'm checking it? I know that's like the common sense logic, but that's not what I'm actually doing. I'm more like check if current letters frequency or count in the anagram and in the hash map is greater than greater than 0. I'm gonna make this 5.1. If it is, decrement the frequency count by 1. If frequency is 0 or less, which less should never happen. If frequency is 0 or less, return false. Because that letter is current letter exists in string t, but not in hash map. Cannot be anagram. If all letters in string t are checked and values are decremented without hitting I want to say like they're checked and the values are all 0. But I don't want to say values are 0 because it's more like, oh no, it should be if all letters in string t are iterated through the hash map values are never 0 or less, return true. Return true. Return true. Add that. So I want to kind of explain why. I'm just going to put 2 because I think that's how it makes it. Because T are now proven to be same size, have all the same letters, and all letters have the same frequency. Therefore, they must be anagrams. want to see if that explanation is correct. Just double checking. Is this explanation correct? Okay, cool. It is correct. And we have all the things. Sick. Let's go, man. Day 3. We're done. How long is this? An hour and 34 minutes? It's fine. I think I learned it a lot today, so it's okay. See you tomorrow.